Okay, so number 7, I'm going to need to graph my function and the inverse. So I need to find the inverse before I can graph it. So when I multiply by 1/4, that's the same thing as dividing by 4, because I can write 1/4 x as x divided by 4. So I need to use that when I write my inverse. So the first thing I did to x was divide by 4. Then I added 2. So with my inverse, I'm going to subtract 2, then multiply by 4. So my inverse is x minus 2 times 4. And I need my parentheses because I am multiplying x and -2 by 4. So you could clear it up by writing that. The calculator doesn't care. It'll graph either one of those. It's the same line. So I'm going to graph this first. So if x was 0, that term wouldn't exist. I'd have 2. So that's my first point, 0, 2. And then from there, I'm going to move up 1 and over 4. And then on the left side, I'm going to go down 1 and then left 4. So that is y. And then my inverse, here if x was 0, that term wouldn't exist, so I just have -8. So at 0, it's -8. So then from here on out, I'm going to add 4. So go up 4 and over 1. So you can see these points that are opposite. That's 0, 2, and this one is 2, 0. And that's 3, 4, and that's 4, 3. It's going to be 4, 8, and that should be 8, 4. So even the slopes are opposite. This one's going over 4 then up 1. This one's going up 4 then over 1. And that's my inverse. So number 8, I'm going to write out my table. First thing I did was square it. Then I added 1. So my inverse, I'm going to subtract 1 and then take the square root. So we talked about when we had an even exponent, the inverse is not going to be a function. So I'm going to start graphing it. If x was 0, I just have 1. And then if x is 1, it's going to be 1 plus 1 is 2. So the same thing goes for -1. It mirrors across. So if x was 2, I'd have 4. 4 plus 1 is 5. And I can just kind of get my parabola from there. So I used -2, 5, -1, 1. That's 2. 0, 1, 1, 2, and 2, 5. So those points I'm going to use with my inverse. So when I write out my inverse, it's x minus 1 in the square root, plus and minus. So 0, 1, my inverse is going to be 1, 0. And that's going to give me 2, 1. And then 5, 2. So that's the positive square root. And then on the negative side, I have negative 1 and negative 2. That's going to be 2, negative 1, and 5, negative 2. So we talked about the vertical line test. If you look at it, any vertical line you draw, our function, the inverse, well, it's not a function. Our inverse is going to cross it twice, making it not a function. So you can see, like, to get this whole parabola and have its entirety over here, we have to have the positive and the negative square root. So it's not a function. Even the calculator won't even graph it unless you tell it you want positive and you want negative. So 9, 10, and 11, I showed you on the calculator. If you put the first one in Y1, the second one in Y2, and then have the calculator in Y3, say Y1 of Y2, and then graph it and see if you get the line Y equals X. They're inverses. So I'm going to do the same thing for all three of these. So in my calculator, I'm going to put in 7x plus 15. And then for g of x, I can use my fraction, the alpha y equals, enter, x minus 15 divided by 7. And then to get the y1, the y2, it's alpha trace. And then I want y1 first, and then parentheses. I have to go back and get y2, close parentheses. And then if I arrow over and hover over the equal sign, I can turn off y1 and y2, so they're not going to be graphed. Now I'm going to graph it. That looks like y equals x. Goes to the origin. I'm going to make sure by going to the table. So even in the table, it's not going to show me y1 and y2. So yeah, all those values in the positive direction, it's y equals x. So for the most part, it looks like number 9 is right. I proved they are inverses. So number 10, it might not look like inverses exactly to you, because the 4 and the 16 and then the 1/4 and the 4, you don't see the same numbers. But I'm going to clear that out. I just want to make sure 4x minus 16, and then alpha y equals, enter. I didn't really need that. 1/4 x plus 4. Again, I can arrow over the equal sign, press enter, and it turns them off. So I'm going to graph it. Looks about right. And yeah. So that's good. So the last one, 3x plus 1 1/3 x minus 1. I'll just graph them all. I have in my settings where they graph simultaneously. I think I typed in something wrong. Nope. The 1/3 shouldn't be there. In the original function, I multiplied by 3 and then I added 1. So in the second function, I should have subtracted 1, then divided by 3. So my function should be x minus 1 divided by 3, not 1/3 x minus 1. So these are not inverses. And the calculator told me that when I graphed it. I don't get the line y equals x. So number 11 is wrong. They are not inverses. So 9 and 10 were inverses, but 11 was not inverse. The two functions were not inverses of each other.